Section 2.2 is the distributive property. I can use the distributive property. Example 1 says, you and a friend are going on a camping trip. You each buy a backpack that costs $90 and a sleeping bag that costs $60. What is the total cost of the camping equipment? So we have two different ways we can do this. We can say that the sleeping bags are one cost and the backpacks are another. In which case, we would have 2 backpacks and 2 sleeping bags. Backpacks cost $90 and sleeping bags cost $60. And we want that total cost here, so we're going to add those together. PEMDAS says we multiply first. And finally we add and we will get $300. The other way we can do this is we can say the total cost of a sleeping bag and a backpack and a sleeping bag, and then we're going to multiply it by 2 because there are 2 of you. So we could figure out how much each of you is going to spend and then double it. So we can see here that it doesn't matter if I take 2 times 90 first and then 2 times 60, or if I add first and then multiply, we get to the same spot. Those 2 examples are called equivalent numerical expressions because they have the same value. They both simplify down to $300. They illustrate the distributive property for evaluating the product of a number and a sum or difference. So if we take a number times a sum, so times something in parentheses, I can take that 4 and multiply it times both pieces. It started off as multiplication, stays as multiplication, it just goes to both the 6 and the 3, for example. And it doesn't matter if that's at the front or the back, or if we're adding or if we're subtracting, it works for all of those situations. So we're going to use this idea. After touring a cave, you visit the gift shop and buy 3 geodes. Each geode costs $5.95. We're going to use the distributive property in mental math to find the total cost of the geodes. So right now I have $5.95. $5.95 is really close to $6. And if we paid with $6, the clerk would give us back a nickel, 5 cents. So I rewrote $5.95 as 6 minus 5 cents. Now we want 3 geodes, so I'm going to take that and multiply it by 3. I know it says use mental math here, but I still want to see your steps. What I don't want to see is $5.95 times 3. Okay, I want to see that you use the distributive property here and split that up. 3 times 6 gives me 18. And 3 times negative 5 cents, we're going to take that sign with it, gives me minus 15 cents. So if I take 15 cents away from $18, I have $17.85. And even though we wrote some steps there, guys, that's still something that we could have done in our head a whole lot easier than multiplying it out pen and paper. 3 times 6, 18. Okay, each time they take away a nickel, that's 3 nickels, 15 cents. 15 cents from $18 gives me 85 cents and $17. So feel free to pause here and give this a try if you'd like. Right now I have multiplication. I have one thing times a sum. So I'm going to take that 3 and multiply it in to both pieces. So I take 3 times the 8, and then I take 3 times the 5. 3 times 8 is 24. 3 times 5 is 15. Now I can add those up because it's a positive 15, and I get 39. And I know according to PEMDAS it says we should add first and then multiply, but we're just getting some practice with this distributive property right now. So again, I can take 2 times 9 and 2 times 2. Because I'm multiplying, I can keep multiplying, take that multiplication to both pieces. So the 2 gets it, and the 9 gets it. Now we simplify. 4 and a positive 18 means I'm going to add, and I get 22. And we can check those by using PEMDAS to see if we get to the same spot. Again, I have multiplication, so I'm going to distribute in. 6 times the 11, 6 times the negative 4. So again, I'm just taking my number parts here. I didn't change these at all. Keep that sign with the number. 6 times 11 is 66. 6 times negative 4 is negative 24. When I subtract here, I'm going to get 42. And on 4, it works the same way. I can distribute that in. Even though it's at the back, I'm multiplying to start with, so I'm going to stay multiplying. I can take negative 5 times my first number and negative 5 times my second number. Those numbers are 3 and a negative 14. Now I simplify each set. Negative 15 minus a negative here gives me a positive 70. And when I add those up, I get 55. Now we're going to evaluate the expression using the distributive property in mental math. So the first thing I'm going to do is I'm going to take my 105 and I'm going to rewrite it. That's the same as 100, which is a really easy number to work with, plus 5. So we're going to try and rewrite these as whole numbers or things with only one digit that's not a 0. So 100 only has the 1 in the hundreds digit, everything else is 0. A little bit easier there. So now I'm going to take this and rewrite it over here. Again, I did not change my parentheses or my 4. I just substituted in what I simplified it to be, and now I can distribute. I can take 4 times the 100 and 4 times the 5. I can go ahead and simplify. 4 times 100 is 400, and 4 times 5 is 20. And since that's positive, I'm going to add. And here, I get 420. And 397 is where I start. And that is going to be really close to 100. To get back to 97, I have to subtract $3. Okay, if something was $97, I paid with 100, I subtract 3. Think about it in terms of money, guys. That's something you guys are pretty familiar with. So, if something costs $97, you pay $100, you get $3 back. So, now I'm going to use this idea here to rewrite 97 as 100 minus 3. And I'm going to bring down the rest of my problem. Here I can distribute. I take that 3 into both pieces. So 3 times both pieces. The 100 and the negative 3. Simplify. And 300 minus 9. When I take 9 away, I get 291. Here, I'm going to rewrite the 2.9. 2.9 is really close to 3. And I have to subtract 0.1 to get back. So, I'm going to rewrite 2.9 as 3 minus 0.1. I didn't change the 5 or the fact that I'm multiplying. Now I can distribute that in as multiplication. I started as multiplication, so I'm going to end as multiplication. 5 times both pieces, both the 3 and the negative 0.1. I simplify here. 15 minus 0.5, and I get 14.5. If I take half away from 15, it drops me down to 14 and a half. 7.02 is really close to 7. And I have to add 0.02 to get back. These two things should always equal each other. Now I take that value and I plug it in. I said that 7.02 is the same as 7 plus 0.02. And that makes it a little bit easier to multiply here. I can take that number outside and distribute it inside since I'm multiplying. Now I have 8 times 7 and 8 times 0.02. It does not matter what is inside our parentheses there, guys. We can distribute regardless. So 8 times 7 is 56, and 8 times 0.2 is a positive 0.16. And that's going to have me end up at 56.16. Two variable expressions that have the same value for all values of the variable are called equivalent variable expressions. We can use the distributive property to write equivalent variable expressions. So it doesn't matter here, like I said on the last one, we can take that 3 and multiply it in no matter what is inside, whether they're just numbers or they're variables. And the distributive property is a lot more helpful here because we can't actually add x plus 7. On the last ones, we could have added those numbers and done PEMDAS, multiplied, got to our answer. Here we cannot. We still take that x and take the 7. We just multiply them both by 3. So 3 times x, 3 times 7 is a positive 21, and I get 3x plus 21. Same idea here on B. The negative 2 is at the back, but that doesn't matter. I can still swing it up and multiply since I started with multiplication. So the negative 2 is my one item. That's the one that I multiply times both of the things inside. So an n and a 4. Go ahead and simplify. And there we go. Same idea here in C. It doesn't matter that it's negative. I'm still going to take that negative 5 to both pieces. So negative 5 times and negative 5 times. I still have the 2y and the negative 3. When I simplify here, I get negative 10y minus a negative 15. 2 negatives make a positive there. Feel free to pause here and give this a try if you'd like. I have multiplication, so I'm going to distribute that multiplication through. I take 8 times, I have two things, so I'm going to take that 8 times both of the things, x and 2. Simplify 8x, simplify positive 16, so plus 16. In 10, I have a negative 4 that's being multiplied, so I multiply it into both pieces. I'm going to take negative 4 times my first piece and negative 4 times my second piece. My pieces are a 7 and a negative t. So when I simplify here, I get negative 28 minus a negative, two negatives give me a positive, 4t. Same thing here. I have a 9. I can distribute that through. It starts as multiplication, so it's going to stay as multiplication. And I multiply it times every term in my expression. So the 3m stays as a 3m, and the 5 stays as a 5. I multiply 27m plus 45. And the last one here, negative 2 goes in to both pieces. I take negative 2, since I'm multiplying to start with, I stay multiplying. The 6y and the negative 4 gives me negative 12y minus a negative gives me a positive. Area of a rectangle is length times width. Here, my length is 7. My width is 2x plus 5. I can go ahead and distribute. And my area is going to be 14x plus 35. In B, my area is half times base times height. My base is 12. My height is 8 minus 3y. I can multiply here and get 6. And then distribute the 6 into both pieces. 6 times 8 is 48, and 6 times negative 3 is negative 18y, and that's my area.